Hey, welcome guys. We're going to do some parabolas. We're going to look at some what are called conic sections, and we're going to take a break from trig, which I'm glad, or I think you're glad, that it's done with for a little while. We're going to come back to some sine and cosine stuff a little bit later when we talk about vectors and parametric equations. But for right now, we're going to go back to what we have done in Algebra 2 and talk about conic sections. So the first part that we're going to start off with is talking about generally what are conic sections, and then talk specifically about the conic section's parabola. Okay, so we're going to talk about, should be able to determine the conic section that's formed when a plane intersects a double-naped cone. What is that? Don't know. And you're going to discuss each conic section is formed when a plane intersects a double-naped cone. You're going to discuss it with me. So anyway, this is a double-naped cone. So if you want to write that down someplace, that's not a bad idea. This is a double naped cone. The key parts that you need to know is right there. Let's get a nice happy green. There we go. That right there is your vertex. And you may need to outline this here because the black and white didn't come out too good. But the two lines that are right here and right here, or any of the outside lines of the cone itself, those outside lines, are called generators. They're lines that I spin around an axis, and when I spin it really fast, I'm not sure if you've ever done it with a glow stick. You spin a glow stick really fast, you make a circle. Well, if you spin it really fast, sometimes you look up at it as you're spinning, it'll make a cone. And this, okay, is what's happening. Is these two lines are spinning around this axis, and it's making a cone. And that's what they kind of look like. That's why they're called generators, because I can make my lines, tilt more to get a fatter cone, or skinny cones, or any type of cones like that. So then what's the great idea about this? Well, what comes next are different examples of what could happen if you take a plane, like a fat piece of paper, and that's what this purple thing is, a plane. So again, if you've forgotten your geometry terms, this right here is called a plane. And if that plane cuts the double-naped cone, or that plane, cuts it such that the plane is perpendicular to the base of the cone. Actually, cones, right? Because perpendicular one is perpendicular to the other. Then guess what? When that happens, when my plane is perpendicular to the cone, I get a circle. All right. What happens if my plane cuts it at an angle? Like that. Well, specifically, what happens when the plane's slope is less than the generator slope, I get a shape called an ellipse. If you don't remember what an ellipse is, think oval. And here's my little shape of the oval right here. Okay. But mister, what happens when the plane is, parallel to the generator? I'm glad you asked. Well, when the plane is parallel to the generator, I get a parabola. And you should know what parabolas are. So I have here my plane. Plane's slope is equal to the generator slope. I get a parabola. And those you're familiar with, and that's what we're going to talk about more later. The last one you may or may not be have heard is when my plane's slope is bigger than or greater than the generator's slope. And when that happens, my plane actually cuts through both cones. Notice every single other one, it only cut through one. But when the generator slope, when the plane slope is greater than the generator slope, it cuts through both of them, and I end up with two pieces that are separated. Got one here and one right here. And those are hyperboles, and that's what your graph would be of a hyperbole. Okay? So that's what you need to know about this. So if they say, if I got a double nape cone and my plane slope that's cutting my double nape cone is equal to the generator slope, they'll say, well, what shape is made? Parabola. That's the way that you're going to need to know this. Okay? So moving on, we're going to talk about specifically parabolas. Okay? And this is everything you need to know for parabolas. This is a very, very important thing. I will have a anchor chart up here inside the classroom for you so you can take a look at it. Okay? But these are things that you're going to need to know. Okay? You're going to need to know what the standard form of an equation is for ones that open up and down, and for knowing for left and right. Other important pieces inside of here that you need to know is that there are three big parts of a parabola. First big part is the vertex. The vertex is the tip of the parabola. Right here. I did it on all three of them. Right here, right here, right here, and right here. All four of them, actually. That's the vertex. The next important point that's on there that you need to know about is what is called the focus point. Okay? The focus point is right here. Right here. Notice the focus point is always inside the parabola. It's always inside the parabola. Those are focus. So again, if you have a little bit of room, you may want to say, hey, F is for focus. F equals focus. Okay? And we already talked about V is equal to vertex. But what is D? D is a line right here. D. It's this line right here. This is called the directrix. D is called the directrix. 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 Okay. So there's all that information. It's a lot. It's a vocabulary. Again, these are things you should have picked up in Algebra 2. The last one, that A, is axis of symmetry. That's the one most everybody remembers, so I'm not going to go over that. The important part here to know is this P part in looking at this. Why is this important? P. Because P is one of the ones that's on there. P stands for, that's your focus or focal length. P is the distance from the vertex to the focus. Okay, P is equal to distance from vertex to focus and from the vertex to the directrix. That is important to know. Like, if you can, circle it, star it, highlight it, do whatever. That's important to know. So here we go. Let's talk about our wonderful examples that we're going to go through. We have 6 of them. Ready, set, break. Example 1. They give me this this formula already in standard form for a parabola. And to help yourself out, hey, this is a y squared one. Y squared. So that means that, hey, this is a sideways parabola because it's y squared, not x squared. I know that's going to open to the left because this is negative. If it's positive, it opened to the right. Okay. So now here they want me to identify the vertex, the focus, the axis of symmetry. So what I'm going to do up above here, I'm going to go ahead and write the standard form that they give you, or they gave you, y minus, k squared equals 4p times x minus h. So I go again and I look up there and I see that vertex is equal to h comma k. So when I do this, what I got to see is, hey, look, this says minus k. So whatever's here, this means opposite. So if this is minus k, so if this looks like a negative 3, that means that my k is really a positive 3. And if this is really a positive 1, it's telling me to do the opposite up there, negative 1. So h is negative 1, k is positive 3. The next thing I'm going to work on is the focus. The focus. Okay, because this is one that is going left and right, my x is going to change. And my change is h plus p, comma, k. But what's p? Okay, so here they show me that there's a 4p in front. So what I do know is that 4p is equal to negative 8, meaning that p is equal to a negative 2. So now I plug in negative 1 plus negative 2, comma 3. Well, a negative 1 plus a negative 2 is a negative 3. That's negative 3, comma 3. And that's my focus. My axis of symmetry. I'll put axis of sim is equal to y equals h, y equals k, which is then equal to just, well, y equals 3. Think that was easy. And last but not least, the last thing that they're looking for is my directrix, which is then equal to x, excuse me, is equal to h minus p. Well, that means that x is equal to negative 1 minus negative 2, which is negative 1 plus 2, which is just 1. So the final answer to that one is x equals 1. And that's how you pull all the information that you want. As far as graphing it, I can come over here off to the side. They say to graph it. And I put in my information. Vertex, negative 1, comma 3. Here's negative 1, comma 3. 1, 2, 3. That's my vertex. I know that my focus is at negative 3, comma 3. So I focus. They tell me then my axis of symmetry is y equals 3. Well, I already knew that, but the main important one is the directrix of x equals 1. There's my directrix. So I know my focus is always on the inside. And I'm going to do that. There it is. There's my graph. I'm just asking a sketch. I'm not asking for perfection. Okay? And I'm asking just a sketch based off of those 3 things. Next. Finally, astronomy. Okay, no, not finally, but astronomy says here the parabolic mirror for California Institute of Technology's Hale telescope at Mount Palomar is a shape modeled by this wonderful parabola where x and y are measured in inches. What is the focal length of the mirror? Focal length. Oops. Went the wrong way. So my focal length, remember I said, that's P. And what do I know? I know that 4P is in front. So 4P is equal to 2668. Divide by 4 on each side, you get 667. What's my unit? In inches. Whew. So even these really big, nice, happy word problems, if you know what you're looking for, is super uber easy. Okay? But now I get to this one. It says, write this in standard form. Identify the vertex, focus, axis of symmetry, and all this. This is going to take up a little bit of space. So it's an x squared, so I know it's going to be y equals a y equals with an x squared. So what I want to do is I want to get all my x's, all my stuff on one side and my y on the other. And you might be asking why. Because if you look at the standard form, you may be saying, hey, I want to get my x's on one side, so I get x squared minus an 8x. I put my y on the other side, I get a y, add y to both sides, minus an 18. And you're thinking, well, I'm kind of close to here. Well, again, remember what my standard form looks like. X minus h squared is equal to a 4p times y minus k. Notice this right here is, this whole thing is squared. Not just x squared like this one, but the whole thing is squared, which means I need to make up a difference of two squares. Now, okay, I need a difference squared. So what does that mean for me? Well, I'm going to try and do some math magic. The way that works is I'm going to bring this over. So I have x squared minus an 8x plus an 18 is equal to y. And this is me kind of thinking ahead. In order for me to know that this is foiling, what do I need? I need this right here, this x minus h, the h part here, needs to be half of this, half of 8. What is half of 8? Half of 8 is 4. So h is going to be 4. But then I remember when I square 4, because when this gets squared, square root of 4 is 16. Oh wait, I have 18 here, not 16. But I can change the way 18 looks. I can say that x squared minus an 8x can now be, instead of 18, I can write 16 plus 2 is equal to y. And then I can come over and break this off, chunk, chunk. When I break that off, I can go ahead and rewrite this as x minus 4 squared. I still have this plus 2, but I'm going to chunk it over to the other side. Is now equal to y minus 2. And now look, this is what we were wanting or shooting for. And now this is what we've got. Notice there's nothing here for me to factor out. Y is already by itself, so I don't need to factor anything out. So there's my information. So again, let's go about our vertex. Our vertex, V, is going to be a positive 4, comma 2. My focus. Well, what is my focus going to be? Well, this is x squared, so I'm moving up and down, so my y is going to change. So 4, comma, y plus, or excuse me, 2 plus p. But what's my p going to be? Well, again, remember, what's out here? What I can't see is a 1. So I know that 4p is equal to 1, or p is equal to 1/4. So that this is now going to be 4, comma, 2 1/4. My axis of symmetry. Okay, again for this up and down one is x equals h. In other words, just what the vertex is. So x is equal to 4. And my directrix, again, this is what's going to change, is now going to be the k minus p. And so k minus 1/4 or 2 minus 1/4 is equal to 1 3/4 is equal to y. That's my directrix. Okay. Again, they're asking for a sketch. So my quick little sketch is this. And then I'm going to go ahead and sketch it in there. 1 3/4 is equal to, okay, so vertex 4, 2. 1 2 3 4 2 1 2. My focus 4, 2 1/4. Directrix right below that. Parabola up. There we go. That's my slope. There's my quick little sketch, and that's all I'm going to ask for. Okay. And we'll go on to see what's next. Actually, we're just going to call that quits, and we'll probably have another one on Monday. Bye.